Hi, in this video we will talk about the nuclear medicine. The nuclear medicine is a medical area dedicated to perform diagnostic studies and treat disease that uses radioactive material, both for diagnostic and therapeutic purposes. Radionuclides. Nuclear medicine is basically focused in the administration of a set of radioactive compounds, which can be given to the patient orally, airway, intradermal, or by an injection. These radionuclides do not have any function inside the body. That is why they should join with a specific molecule with a particular metabolic behavior, like technetium, that is used only for diagnostic purposes. Nuclear medicine consists in obtaining anatomic and metabolic images. These images are obtained by the energy detection supplied by the radiotracer. Certain types of cancer can be treated with a medical nuclear therapy. Most of the times, if it is combined with a correct diagnostic, the therapeutic results can be successful. Radioactivity. It is the property of certain unstable isotopes whose number of protons and neutrons are not in balance. He can involucrate the mass number that he is in the chemical table, the number of the top right. Types of radioactivity. Alpha. The alpha radiation can only go through a very small distance and can be stopped by a sheet of paper or the skin of the human body. Beta. The beta radiation can go through the air for a distance of about 1 meter and can be stopped by a few inches of wood or a metal foil. Gamma. The gamma radiation can travel hundreds of feet into the air and can be stopped by a thick wall of lead or cement. Radioactivity decay. There are only a few ways in which the nuclei can decay, while each type has its own core decay mode. Alpha decay. An important group of heavy elements can decay by emitting alpha particles, consisting of an aggregate of 2 protons and 2 neutrons. These alpha particles are identical to helium nuclei. Beta decay. There are 2 types of beta decay, the one of the negative particle and the one of the positive particle. The negative emitted beta particle is an electron with its corresponding charge and mass, which is indistinguishable from the electron's charge of the atomic layers. Since nuclei do not contain electrons, the explanation of this emission is that a nucleus neutron becomes a proton and an electron. The resulting proton stays inside the nucleus by virtue of the nuclear power, and then the electron escapes as a beta particle. The mass number of the resulting nucleus is the same as the original nucleus, but the atomic number is increased by 1, thus preserving charge. Gamma decay. Gamma rays are photons or electromagnetic radiation package, including visible light, ultraviolet, infrared, X-rays, microwaves, and radio waves. They have no mass and no charge, and only provide energy emitted waveform. Consequently, when a gamma ray is emitted by a nucleus, it remains as the same nucleus, but in a lower state of energy. Radiation average life. The radiation has a half-life, which is called as the average life period of disintegration or of radioactive material, and it refers to the time required for the half of a given active amount atoms to disintegrate. The model that best fits behavior is an exponential decay, as it is shown in the image. Radionuclide. A nuclide is one of the different configurations that can have a nucleus for the same chemical species. It is called radionuclide to a chemical element that has lost or released a neutron or proton, thus reducing its mass number, and can be an atomic nucleus characterized by emitting ionizing radiation in order to transform into another, which at the same time may or may not give out radiation, up to achieve nuclear stability, transforming into an stable nuclide. Main radionuclides. Technetium-99. Technetium is one of the most commonly used radionuclides for diagnostic studies. It's an artificial element that cannot be found in nature and was discovered in 1937 by Carlo Pereira and Emilio Gino Segre, and it have an average life of 6 hours. Fluorine is the radioisotope provided by fluor-19, which is the only stable halogen and the most radioactive and electronegative nonmetal. Is the positron emitter detected by the gamma cameras used for the positron emission tomography, PET, and its average life is of about 1.83 hours. At very low concentration, 18 fluor joins to the deoxyglucose for all those detection areas for showing the glucose accelerated metabolism in organisms or tissues. Iodine-131 is another halogen which has been used in medicine due to its favorable characteristic to study the thyroid gland metabolism. It has an average life of 8.04 days. A lot of molecules can be labeled organic and inorganic, such as antibodies and peptides, for a stable substitution of one atom of iodine-131 or iodine-125.
The gamma camera. The gamma camera is a device that allows the realization of nuclear medicine studies using intravenous injections or inhalation of radioactive substances. This material is deposited in different organs, allowing visualization thereof by radiation emitted and captured by the head of the machine. The equipment consists in a calibrated shield so that the evaluated radioisotope radiation may only reach the detector. A scintillation radiation detector, which is a crystal that emits light by imposing radiation, then is detected by a photomultiplier array. After the photomultiplier arrangement, an electronic system is detecting, counting, and cataloging these events to build up a distribution map of the radiation detector front. The intensity of the detected radiation will depend on both the distribution and the attenuation of the radiation that takes the part of the patient that stands between the point where the certain event took place and the detector. SPECT is a medical technique that uses gamma rays. It's very similar to radiograph, but uses a gamma ray sensitivity camera. As a radiograph, each of the images obtained are two-dimensional, but may combine many images taken from different positions around the patient to obtain a three-dimensional image. This three-dimensional image can then be manipulated by the computer to obtain dimensional body sections in an orientation. This equipment uses the gamma rays. These rays produce radioactive isotopes such as technetium-99. These isotopes are introduced into the human body as part of biologically active molecules. The procedure is similar to the positron emission tomography, but in SPECT is the isotope which produces gamma rays. SPECT is simpler because it can be used more accessible isotopes and with longer half-life. The gamma camera is rotated around the patient. Images in angles are acquired, typically every 3 to 6. In most cases, a full 360-degree rotation reconstruction is performed, allowing the reconstruction of images in 3D. Each image typically takes 15 to 20 seconds, so the whole process takes about 15 to 20 minutes. PET. The positron emission tomography is a non-invasive imaging diagnostic capable of measuring the metabolic activity of human body. Like other nuclear medicine diagnostic techniques, such as SPECT, PET is based on detecting and analyzing the adopting three-dimensional distribution of an ultra-short half-life, radiopharmaceutical administered through an intravenous injection. Depending on what you want to study, different radiopharmaceuticals are used. The image is obtained by the scanners capable of detecting the gamma photons emitted by the patient. These 511 electron volts gamma photons are the product of an annihilation between a positron emitted by the radiopharmaceutical and an electron from the patient. This annihilation produces two gamma rays. These two gamma rays go in antiparallel directions, and its simultaneous detection allows isotope locate more accurately. These two photons create the image by the eventual registration of them, and this means at the same time and at an appropriate time window. These two photons must also come from opposite directions.
And that's all.